Get into our matrix operations here. Like I said, this is pretty darn easy, so I think we can go through it pretty quickly. The matrix multiplication is probably the new stuff, the not quite as intuitive part of this lesson. So we're going to do a couple more of those, but adding and subtracting, all that good stuff, pretty easy. So we've used mostly our matrices to solve systems of equations. Well, matrices come up, like I said, computer programming, definitely an application there. Different operations you want to be able to do with your matrices. So we're going to hit the easy ones in here. We're going to do equality of matrices, adding, subtracting, multiplying. Equality, I mean, if I just gave you this problem and just said, what equation would you set up to solve for x? Well, I find here x in that expression. What does that correspond to in the other matrix? What number? 5. You set those equal and then you solve for x. It's pretty exciting stuff. All right, you can probably just mentally solve that. Do it in your head. We don't need work. X is... Yeah. Okay. Then I'm going to get wild and do y. Well, 3y corresponds to 12 in the other matrix. You can probably do that one in your head. Y is 4. Not even sure why I'm writing the 12 equals 3y, but I just thought I would. Okay, and then we're going to do z, of course, corresponds to 4. You might even be able to solve that one in your head. Do it in your head. Z is 6. That is equality of matrices. No need to cover that anymore. Notice, too, for equality of matrices, the matrices need to be the same dimensions, the same size. So like, remember, this is a 3 by 4, so that way you have corresponding entries. The reason I'm talking about that is that's also important when we do addition and subtraction. Okay, so that's what we're next on. Addition and subtraction. You can add or subtract them. They have to have the same dimensions or size, whatever you want to put. Because if they're not the same size, you won't have corresponding entries. You can't match them up. You can't match a 2 by 2 up with a 3 by 3. You'll be missing some numbers. So they have to be the same size to add or subtract. If they're not, you just say not possible. Easy enough. Okay, scalar multiplication. All you're going to see for that is a number in front of the matrix. I think of that as kind of like distributive property. You just multiply everything inside the matrix by the scalar. All right, let's go. So you get all these lovely matrices. Let's perform these operations. So a plus b. Now all we're doing is matching up the numbers and adding them. Now a and b are the same size, so I'm just going to start adding. 2 plus 1. And it doesn't matter if you go across or up and down first. You just have to do all the corresponding parts. 0 plus negative 3. 7 plus 2. Now I'm going to do the other column. Negative 3 plus 0. 5 plus 1, and we're going to live on the edge with a fraction. What's negative a half plus 2? 1 1/2, 3 halves. I don't care how you write it. That is matrix addition. Woo, let's do subtraction. Okay, C and D are the same size, so I just always double check that before I start doing extra work, of course. Now I'm just going to subtract. 7 minus 6. 0 minus 8. And again, the order you work in doesn't matter. Just do all the corresponding parts. Negative 3 minus 0. 1 minus 1. 0 minus negative 6. 5 minus 9. So this is why I said I think it's actually quicker. I mean, can you do this in your calculator? Yes. Do I think it's quicker to just add them and subtract them in your head. We can do a little mental math. All right, C plus A. I don't like it. What's wrong with C and A? Different sizes, we can't match it up, we can't do it. Not possible. All right. Let's do 5A. All you have to do is multiply everything in A by 5. 5 times 2, 5 times 0, 5 times 7, 5 times negative 3, 5 times 5. Ooh, in the fraction, what's 5 times negative a half? Negative 5 halves, 2 1/2, however you want to write it. Didn't really space that out picture perfect with the fraction, but hey, we got it. That's adding, subtracting, and scalar multiplication all in one very lovely problem. Any questions on those? Love this section. Okay, just some properties up here as far as matrix addition goes for whatever it's worth. Remember, adding, the order doesn't matter. 2 plus 3, 3 plus 2, you get the same thing. So you could have added those in the reverse order, you would get the same thing. Not true for subtraction, the signs would be switched, but just throwing that out to there to you. If you have, and you rarely see this, but if you have multiple scalars, let's say besides just 5a, I also put a 2 in front. Why not just make it 10? So you can multiply your scalars together first and then distribute it, or distribute each scalar separate, which just seems dumb to me, okay? And again, same thing here, like if you are adding and you have a scalar, you could distribute the scalar first and then, of course, add them. So there are some options, but of course, kind of common sense, I always think PEM does, I would do parentheses first, I'd add those together, then run the scalar through at the end. Why make it any more complicated? But just wanted to point those out too. Okay, last thing we're going to do for solving and the adding and subtracting and all the good stuff before we get to multiplication is solve the equation for x. So we're going to have a matrix style answer for this, but first thing I'm going to do is just isolate x in that equation. I'm going to add the a over. And then of course I'm going to get rid of the 2. Now, we really haven't talked about dividing matrices. We've talked about scalar multiplication. So dividing by 2, of course, is the same as multiplying by a half. So probably the quickest, easiest way to calculate our matrix style answer is I'm going to add a and b, because that's pretty quick and easy, and then I'm going to run the scalar of a half through it. Multiplying by a half is the same as dividing by 2, obviously. Now I'm just going to do those operations. So first I'm going to do a plus b. Let's start with that. So I'm just going to add my corresponding entries. 2 plus 4, negative 5 plus 1, 3 plus negative 1, 1 plus 3. And then to get our final answer for x, we're going to run a half through that. And again, can you do all of this in one step in mental math? Sure. I'm just separating it out for your notes here. So half a 6, half a negative 4, half a 2, half a 4. Gotta love this section, okay? Any questions on that? So, last thing I have to show you today, because we blasted this lesson, matrix multiplication. Now, don't get ahead of me, because it is not as simple as matching up the numbers and multiplying them. There's a little bit more of a process in it. It might remind you of some old school vector dot product. Not cross product, dot product, okay? So, matrix multiplication, let's talk about it. So the number of columns in the first matrix has to match the number of rows. And you'll see this in a minute. Key is we use what's called the row column rule. So first things first, I always check the size, meaning, okay, size of A, 3 rows, 2 columns. Okay, size of B, clearly it's a square, 2 by 2. So the first thing I'm going to check for every single time, and you'll see why in a minute, I'm going to check that these inside dimensions match. The number of columns matches the rows. It does, we can do it. If those didn't match, we wouldn't be able to do it. We'd say not possible and go on with our lives. Now, the nice thing is these outside dimensions will be the size of my answer. So I'm kind of mentally in my mind like, okay, I need room for 3 rows, 2 columns. So I'm kind of spacing that out in my head. So I'm like, ooh, 3 rows. I'm going to kind of stack it tall and leave yourself some room on the side here because I'm going to write some numbers. And then like 2 columns. Okay. Kind of space it out. Now, remember, we are using what's called the row column rule. So that means the rows from the first matrix. So my first row in A, I'm going to jot them down, -1 and 3. Second row in A, and then my third row. So I did pretty good on the spacing. Might be a little tight there. And then I'm going to look at the columns of B. -3, -4. So that's the first numbers I'm going to jot up here. And then to get my second column answer, I'm going to put the 2 and the 1. So I'm going to, yeah, it's kind of like a Punnett square. So I'm going to kind of do the math, and then we'll total them up too. Okay, so it is kind of like a Punnett square. We're just pretty much, like I said, it reminds me of vector dot product, because I'm going to multiply these together. I'm going to multiply everything and add them together. So I'm going to do -3 and -1, got it? 3 and -4. Now, some kids like to do all the multiplying first and total at the end. I don't care, I'm going to total as I go. 3 minus 12, there's my first entry on my answer. Now, it doesn't matter if you go across, up and down, we're going to fill in the whole darn matrix. I'm going to go up and down. 4, -3, -2, -4. I'm going to add that together. And I'm going to do the lower left corner, 5, -3, 0, and who cares, -15. Ooh, that's a very sloppy negative sign. Okay, I'm going to move over to my next column. -1 and 2, 3 and 1. I'm going to combine it. Now I'm in the middle here, right middle. 4 times 2, -2 and 1. 5 and 2, 0 and who cares. Got it. So a little bit more involved in adding, subtracting, and scalar multiplication, but still not difficult, okay? So remember, it's the rows of the first matrix, columns of the second matrix. So let's do a couple more of these to practice, because this is really the only, I can't even say it's complicated, but new thing. So first let's check the size, dimensions. So A, there are 2 rows, 1 column. B, 1 row, 1, 2, 3, 4 columns. So first question, can we do it? Yeah, those inside dimensions match. What's going to be the size of your answer? 2 by 4. So I'm kind of spacing that out in my head, 2 rows, 4 columns. Okay, 2 rows. Now, this one is actually easier than the last one because each row, each column, only has a single value in it. We don't have as much adding to do. So first row in A is a 5. Second row of A, 6. Then I'm going to do the columns of B. Well, there's only a single number in the first column, single number in the second, the third, and the fourth. So we just have to, of course, fill in the matrix, fill in the grid, so to speak. But they're each a single number, so I won't have to add anything. I just have to do all the products. 5 and -3, 6 and -3, 5 and -1, 6 and -1, 5 and -5, 6 and -5, 5 and -9, 6 and -9. Got it. Did you grab an assignment, Connor? Okay. Any questions on B? All right. Home stretch. Always check the size here first. So A, of course, 2 rows, 3 columns. B, a little square. Hey, I like this one. I can't do it. Those inside dimensions don't match. If I tried to do it, let's say I was just like, man, I'm in the zone, I'm just going to row column, I'm going to write it out. Here's going to be the problem. You'll run out of numbers. You'll have 3 values in the row, but you only have 2 in the column. You won't have enough to match up. So even if you didn't check the size, you would quickly see you're not going to have enough numbers to keep it even and multiply them all out. All right, let's take a look at this guy. So check the size first. Lord knows we don't want to do extra work. So first one, of course, nice square, 3 by 3, 3 by 2. So definitely we can do it. Again, I'm just kind of mentally spacing out my size there. And then I'm going to, of course, show you something in the calculator when we're done. So 3 rows. Okay, rows of the first matrix. So now this just means more work. Each row, each column has 3 values in it, so we're going to have to multiply a lot of stuff here together. Second row, 3, 0, 4, and then 4, 2, -3. Now, do you have to write the numbers down on the outside? No, I have some kids that can just mentally look at it and match them up and do it. I just write them down for your notes so you know exactly what I'm multiplying together. Okay, column in B, 2, 1, -5. And then 7, -1, and 3. Okay, So we got a lot of multiplying to do because there's so many numbers. So we're going to do all the multiplying. I'm going to total at the very end. Negative 1 and 2, 1 and 1, positive 1, so I put a plus, negative 2, negative 5. I'm going to go back through and total all of the 3 and 2, 0 and who cares, 4 and negative 5. 4 and 2, 2 and 1, negative 3, negative 5. And we'll total those up in a second. All right, let's get this last column going. Negative 1 and 7, 1 and negative 1, negative 2 and 3. 3 and 7, 0 and who cares, 4 and 3. 4 and 7, 2 and negative 1, negative 3 and 3. And just total it up, my friends. All right, so what do you have for your top left entry?
9.
Thank you. Second one, underneath, negative
14. 25.
Like it. Over here, we've got negative.
40.
Agree. Final two. What do you got for this one?
17.
Perfect. Yeah. Any questions on that? Now, just like we've been talking about, I'm going to pull up the calculator. You get yours out. Let me erase this so we can see what the numbers. So there will be a calculator portion, obviously, on your test. I'm going to slide that down so I can see what B is. Now, obviously, it's going to be up to you. Just because you're on the calculator part of the test, do you have to type it in the calculator, or could you do it by hand? Well, that's really up to you. It's going to be your call. But I'm going to show you for the calculator part how, especially if I gave you, not that I'd be too mean, let's say there's some fractions or something there, we're pinched for time, we just want our calculator to do it. So, I'm in my matrix menu. I'm going to go over to edit. Notice I cleared by now and I was using it in trig earlier today, so I got nothing in here. So course A, let's type that in. We got a 3 by 3. You know how to do this, just start typing them in. Negative 2, 3, 0, 4. And I'm just going to double check I don't have a typo because you know I hate typing on this thing. Got it. Then once you have A typed in, I'm going to just go back to the matrix menu and edit and put B in. So I've got A in, back into my matrix menu to edit again, and I'm going to do number 2, letter B. And I'm going to type that guy in. He's a 3 by 2. 2, 7, 1, negative 1, negative 5, and 3. Let me make sure I don't have a typo. Okay. So of course, once you have them both typed in, remember any actual math or calculating that you do, you have to be on the home screen. So I have to quit out. And now I want my calculator to do matrix A times matrix B. So I'm just going to end the matrix menu. A is highlighted. I'm going to hit enter. Do you have to put the times sign in? No. Remember, your calculator will know to do product. If you want to be dramatic, I'll be dramatic and put the times sign in. You don't have to. It would still know to do product. And now I'm going to pull up my matrix B, number 2, and I'm going to hit enter. And there it is. Okay. Is it faster than by hand? I don't know. I think it depends how quick you type on it. But there will be a part of the test. There is a part of the homework where you can do on your calculators. I don't need any work. You can type it and write it down. So you just need to be proficient at both. Any questions on our calculators? Adding and subtracting, I think, is quicker by hand, personally, than typing them both in to have it added. Unless, you know, I gave you a bunch of junko fractions, I guess. Okay, last thing, just for whatever it's worth, of course. Sometimes I think this stuff's more of a headache than what it's worth. If you're multiplying like 3 matrices, I never make you multiply 3 probably by hand. Of course, you can pick whatever 2 you want, multiply that by the third. If you're adding, again, I can't say as I would distribute and do a lot of product. I would follow order of operations. I'd add B and C, and then I'd multiply with A. Same thing on this one. So just showing you some different options. Again, I just always follow order of operations. That is how I roll, my friends. So any questions on our calculator or anything? Okay, let me grab your